Hello again. Today's video is going to be the very end of talking about atoms. Some of these things we're going to definitely come back to again at the end of the next topic, but just to touch on it so that you have an idea of what's coming up. The last part I wanted to really talk about is the periodic table, just to make sure we're all on the same page. Whenever you hear the word table, you typically think of columns and rows. Right? If you were in Excel, you'd have columns and rows. In the periodic table, we have columns and rows, but we don't refer to them as columns and rows. We call columns groups, and we call rows periods. So when you look at a periodic table, hydrogen and helium are the only two elements that are in the first period. And so this is period 1. This is period 2. The next one down is period 3. And the first column would be group 1. And the next column would be group 2, and so on. So I'm going to actually show you some periodic tables, and I want to just put some terms down, and then I'm going to come back and tell them, go over the terms while we're looking at the periodic table. So first is some of the groups have names. And the names that you should be familiar with are group 1 are called the alkali metals. Group 2 is called the alkaline earth metals. Groups 3 through 12 are pretty much the transition metals. I'll show you what I mean in a moment. Remember from a previous video when we were talking about types of elements, we had that zigzag line, and on this side were the metals, and on this side were the nonmetals. And over on the nonmetal side, if you, along this line, except for aluminum, right, along this line was the metalloids. When you get over to groups 13, 14, 15, and 16, they have no names. But when you get to group 17, those are referred to as the halogens. And group 18 is called the noble gases, or sometimes it's called the inert gases. And so when you're looking at a periodic table, let's look at one for a second. Say we're looking at this version of a periodic table. This has it all color coded for us. So if you look, group 1 is in red, and these are the alkali metals. Notice hydrogen, even though it's in group 1, is not considered an alkali metal because hydrogen has all the characteristics of a nonmetal. It's only in group 1 for another reason that we'll come back to. Some people actually put hydrogen above the halogens. It also has some things in common there, but traditionally it's put above group 1. The ones here in kind of a golden orangish color, these are our alkali earth metals. This part here in the light blue, that's from groups 3 through, and this one it's only 3 through 11. Most of them it's 3 through 12. I'll show you another one just to show you there's some discrepancy between periodic tables that you might look up. These are the transition metals. The ones here in this kind of yellowish mustard color, these are the metalloids. Group 17 is the halogens, fluorine, chlorine, bromine, and iodine. And then helium through radon, these would be your noble gases. So in the previous video, remember I was telling you that the periodic table is set up in order of increasing atomic number. So in the box for hydrogen, you see the value 1. That's because hydrogen's atomic number is 1. Helium's atomic number is 2, lithium is 3, beryllium is 4, and so on. Now notice when you get down here at barium, the barium's at 56, and then it jumps over to hafnium at 72. These elements right here are actually placed down here, and these are called the lanthanides because lanthanum is the first element. And the same thing happens down here after radium. When you get down here, elements 89 through 103 are down here, and these are called the actinides. When we come to the segment on electron configurations, I'll explain to you why it looks like that. But notice on this periodic table, the transition metals stop here at copper, silver, and gold. But if I look at a different periodic table, this one's a little more simplistic, it shows in yellow the transition metals, and it includes zinc, cadmium, mercury. So different different periodic tables might show you slightly different things. I wouldn't get too worried about them. It's not the end of the world. Most people just consider this group of metals to be the transition metals. So those are just some things about the periodic table. So if I were to ask you what element is existing in period 5, groups 14, you would have to go down to period 5 and then over to group 14, and you'd come to SN. SN is tin. So you would find the element that way. So this is a very simplified, nice to use periodic table. It just shows the atomic number and the group number and the period number. If you noticed on the other periodic table, there's a lot more information on each box. It has the atomic mass for each of the elements on there, and then it gives some more information. You can find periodic tables that give even more information. Down here is what this one has, electron configuration information that we're going to use in the next topics. So the other thing I wanted you to notice on this periodic table is the groups are numbered 1, 2, 3, 4, 5, 6, all the way to 18, but some of them also are shown in these Roman numerals. These Roman numerals are the older way of marking the periodic table, and if you ever see people refer to that, group 1A is the same as group 1. Group 13, notice, is only 3, and group 14 is 4, 15 is 5, 16 is 6, and 17 is 7 in Roman numerals. So don't get too hung up on that. I'm not going to use the Roman numerals. We're going to use the 1 through 18, but you might come across, if you look on other websites and things, you might see the Roman numerals, and you could always just look at a periodic table that shows both so that you don't get confused by that. Okay, so that's what you need to know about the periodic table. The last thing I wanted to talk about to finish off the segment is, what about things that are not atoms? So remember that we said atoms are neutral, right? And if atoms are neutral, then the number of protons is equal to the number of electrons. And remember, the number of protons is given by the atomic number, and the atomic number is found on the periodic table. So if you're asked how many electrons are in an atom, the number of electrons in an atom is equal to the number of protons, and that can be found on the periodic table just by finding the atomic number for that element. Now there are other things, and we're going to talk about them in much more detail in an upcoming videos. Not all things have the same number of protons as electrons. If they are not neutral, then what we're going to talk about are things called ions. Ions have an overall charge. They are not neutral. Some ions are going to be positively charged, and some ions are going to be negatively charged. If they're positively charged, they're called cations. If they're negatively charged, they're called anions. If it's a cation, it means that the number of protons is greater than the number of electrons. You have more positives and you have less negative, right? So overall, you're positive. If you're an anion, the number of protons is less than the number of electrons. This means you have less protons or less positive, and you have more negative. So if you're using the TRO as the textbook, they go into ions right now in more detail. We're going to come back and talk about ions and how they're related to the periodic table in a later segment. But if you want to refer back, it's the simplistic view is in this chapter, but we will come back to it. So that's all the information I needed you to know on atoms for this point, at this point.